Well, hello there. This is Mr. Bauer, and we want to just briefly touch on some more graphing linear function stuff. And let's start by looking at something in function form. Okay? Here is an equation that's in function form. The only difference from what you're probably used to seeing this is in function form. The only difference is instead of a y, there's an f of x. And basically, what you're going to come to grips with is that y and f of x are the same thing. Okay? And they're going to ask you something like, find the value of x where f of x equals 10. Well, if these are the same thing, then can't we just plug a 10 in here? And now we've got an equation that we can solve. We could subtract 1, 3x equals 9, divide everything by 3, and come up with x equals 3. And so if you put a 3 in for x, you get a value of 10. Or we could say f of 3 equals 10. Okay? So if they're going to ask you to find the x value from function form, that just means you're going to set whatever this is equal to, in this case, the 10. Or whatever, all right? What if they would have said find f of 5? Well, then you would have put a 5 in for x, 15 plus 1, 16, and you could say, well, f of 5 equals 16. F of 3 equals 10. F of 5 equals 16. All right, so some things with function form there, what they're going to have you do. The next thing they're going to do here, they're going to give you some story problems probably. The good news is they're going to give you a function right inside the story problem. Okay? So, you know, there's a text message story problem in your notes. It says a wireless communication provider estimates that the number of text messages M sent over several years can be modeled by the function M, number of texts, equals 120t plus 95, where t equals years since, that's a since, 2002. Okay? M was text messages. By the way, it was in millions. And T is years since 2002. And basically it says graph it, graph the function, and identify domain and range. Okay? Identify the domain and the range. All right, well, let's make an XY chart. Okay? All right, and really, it's more of a T and an M chart, I think. Okay? You know, would it make sense that if I was going to put this in slope-intercept form, it would look kind of like this, where the T is the same thing as the X and the M is the same thing as the Y? Yeah, I think so. So if we're talking about the actual year 2002, what value should we, if it says years since 2002, well, how many years since 2002 is 2002? Well, it's 0, isn't it? And so, yeah, if we put a 0 in here, okay, if we take 120 times 0 plus 95, what's 120 times 0? 0 plus 95. Don't we get 95? Yeah. Now, what would 1 stand for? What year would it stand for? 2003. Very good. And so you'd take 120 times 1. Well, that's 120. Plus 95. Well, I think that's 215. Okay? You know, and you can go 2004 and 2005 and 2006 and so on and so on. I think I can see a pattern after this one. 240, all right, 240 plus 95 I think is 235. And I don't know if you know this or not, but you're just adding 120 each time. So that would be 345. This would be 455. I think that's right. No. 355, 475. Sorry, I'm so sorry. is you got to add 120 here. That's how you get 35. So you add 120 here, 55. Add 120 there, 75. Yeah. Okay? So now that you have those numbers, you could graph it, and you want to be careful here. You can go by ones, since this is 0 and 1 and 2 and 3 and 4 and 5, but you do not want to go by ones right here, do you? No. It might be smarter to go by hundreds. Okay? And so 0, 95 is about right there, isn't it? 1, 2, 15. I'm such a moron. Does everybody know that this would be 335, and this would be 455, and this would be 575, wouldn't it? Yes. Thank you. Thank you for not... It's the bad thing about online. You can't yell and scream at me when I got it all wrong, can you? So 2, but hey, guess what though? The good news is I was going to figure that out, because when I started graphing this, that line was not going to be straight. And I would have known I screwed up somewhere over here. Okay? So now we go to 2, 3, 35. That's over here. Yeah? Then we go to 3, 4, 55. And we go to 4, 5, 75. Yeah, I see that. Okay? Now I got myself a straight line. Okay? So what's our domain here? What values of x are we using? Aren't we using all the positive values? Or we're using the ones that are greater than or equal to 0? And as far as our range is concerned, it's going to keep going up, but how low? What's the lowest it can go? Well, isn't that the 95? Okay? So it's greater than or equal to the 95 million here. Okay? So that's how you determine your domain and your range there. All right? Good. Now, the last section they want you to do here, they want you to compare this graph, or what we could refer to as y equals x. That line, I don't know if you know this, but that line would be like the order pair 1, 1, and the order pair 2, 2, and the order pair 3, 3. It's like a horizontal line that cuts that. I missed every point there, but you get the idea of where it would be. Okay? Now, what I want you to know about this is a couple things. First of all, if I change the slope, okay, if I put something in front of there like a 2, I just changed the slope of this line, didn't I? Okay? Well, now, what does that do as far as ordered pairs? If you put a 1 in there, you get 2. If you put a 2 in there, you get 4. So 1, 2 is here. 2, 4 is up there. Describe what it did to the slope of my line. If you were walking up this way, didn't it just get a lot harder to walk? So I view this as a steeper slope. It's all positive, isn't it? Did you know that as you go up to the right, you're always looking at a positive slope? Yep. And so if I were to make this a fraction, like 1/2, instead of getting steeper, it wouldn't be as steep, would it? It would be flatter. Okay? That's going to have a flatter slope. Still positive, all right, but it's flatter. As soon as I change this to a negative number, now I have a line like this, don't I? Lines that go down to the right, those have negative slopes on them. Okay? So as you change the slope in front of that, you change the number in front of that x, it's going to either get steeper, or it's going to get flatter, or it's going to change directions totally. It's going to go up to the right if it's positive, it's going to go down to the right if it's negative. All right? One other thing you need to be aware of, and that is if you start out with this normal y equals x, we call this the parent function, okay? It's the mother of all straight lines, okay? Here it is. If I was to go and add something onto the side of it, instead, if this is slope-intercept form, this was x plus 0, and now this is x plus 2. What did I change? Didn't I change the y-intercept? I sure did. And now that line would be right here, parallel to that one, because they have the same slope. All right? So if you add something, you'll move that line up What if you went like this? What would you do to it? Oh, guess what? You would move that line down. Okay? So you can compare and kind of see, all right, I know what y equals x looks like, and now I know what this is going to look like based on did it change the y-intercept or did it change the slope, the steepness or the non-steepness of that line. All right? Good for you. Good luck.